Welcome to the Explainer. Today we're diving into how to implement advanced file security in a Cisco SD-WAN environment. We're going to take some pretty dense technical documentation and turn it into a practical guide you can actually use.
Okay, so here's the game plan. We'll kick things off by understanding the kinds of threats we're really up against these days. Then we'll unpack Cisco's core defense strategy, this before, during, and after model. From there, we'll follow a single file on its journey to see exactly how this all works in real time. And finally, we'll jump into the configuration and wrap up with the key things you absolutely need to know to get started. So first things first, let's set the stage a bit. The fundamental problem we're trying to solve here is that the malware we're seeing today is incredibly good at hiding. It's built to be stealthy. Yeah, this quote from the documentation really gets right to the point. The firewalls and intrusion prevention systems we've depended on for years, well, they just aren't enough anymore. Attackers know how those defenses work, and they design malware specifically to tiptoe right past them. That means we need a smarter, more adaptive approach. So what's Cisco's answer to this challenge? Well, it's not a single product or a one-time scan. It's a whole philosophy, a continuous cycle of protection that covers the entire life of a potential threat. This whole strategy really rests on three pillars. The before part is all about being proactive, hardening your defenses. During is about stopping the known bad guys at the front door. But the after phase, that's the really cool part, the real game changer. This is the system's ability to go back and find threats that looked harmless when they first came in. It's like having a detective on the inside constantly re-examining the evidence. Okay, theory is great, but let's see how this actually works. We're going to trace the complete journey of a single file, right from the moment a user clicks download. We'll follow it through every security check until we get a final verdict. This is where it all comes together.
All right, this diagram is basically our roadmap. On the left, you've got the user at a branch office. In the middle, that's your SD-WAN edge device, acting as the security guard. And over on the right is the brains of the whole operation, the Cisco Secure Endpoint Cloud, which you'll hear called AMP, and the Threat Grid Sandbox. Let's walk through it. The whole thing kicks off the second user tries to download a file. As it starts coming through, the WAN edge device intercepts it and calculates a SHA hash. Just think of that as a unique digital fingerprint for the file. The beauty of this is its efficiency. Instead of sending a massive file up to the cloud, it only has to send this tiny little fingerprint for the first check.
So the WAN edge takes that fingerprint and shoots it up to the AMP cloud. The AMP cloud is like this gigantic global intelligence database that knows the reputation of billions of files, and it's going to respond almost instantly with one of three possible answers.
Let's start with the easy one. If the cloud recognizes that fingerprint and knows for a fact that it belongs to malware, the verdict comes back malicious. The WAN edge immediately kills the download. The file never even reaches the user. Threat neutralized. Simple as that.
The second scenario is just as straightforward. The AMP cloud sees the hash and says, oh yeah, we know this one. It's perfectly safe. Maybe it's a legitimate Microsoft update or something. The verdict is clean, and the WAN edge lets the download proceed without any interruption for the user.
Now, this is the one that really matters for stopping advanced threats. What happens if the AMP cloud has never seen this file before? The verdict comes back as unknown. And here's the clever part. To avoid hurting productivity, the system lets the user download the file. But, and this is a huge but, at the exact same time, it sends a copy of that file over to the Threat Grid Sandbox for a much, much deeper look.
And this right here, this is that after phase in action. Let's say the sandbox runs that unknown file and discovers it's doing some really nasty stuff. It immediately triggers what's called a retrospective alert. See step 8 in the diagram? That's the verdict update flowing back. An invisible threat that was already on your network is suddenly exposed, and you get an alert telling you exactly where it is and what to do.
So Threat Grid is basically a digital forensics lab in a box. It takes that unknown file, puts it into a safe, contained environment, the sandbox, and lets it run wild, all while watching everything it does. Does it try to encrypt files? Does it try to connect to a known command and control server? It delivers a verdict based on what the file actually does, not just what it looks like. Okay, so we've got the concepts down. We know how it works. Now let's switch gears and look at how you actually build the security policy to make all this happen. We're going to head into the Cisco vManage interface.
This is pretty much your command center for file security inside vManage. It's all right here on one screen. You can see the two main sections, File Reputation, which handles that initial quick fingerprint check, and File Analysis, which is how you turn on the deep dive Threat Grid Sandbox. Let's break down what you're looking at.
So, setting up the basic policy is really easy. First, you decide what traffic you want to inspect. You can target specific VPNs or just have it look at everything. Then, you pick the AMP cloud region that's geographically closest to you to get the best performance. And finally, you just set how detailed you want your alert logs to be. That's pretty much it. Now, to turn on the heavy-duty sandbox analysis, you just flick this file analysis toggle. The most important thing you'll need here is an API key. You can think of it as a secure password that lets your SD-WAN setup talk to your threat grid account. From there, you can even get really specific and choose which file types, like PDFs or Office docs, you want to send for that extra level of scrutiny. Okay, before we wrap up, let's just cover a few essential things you absolutely need to know before you start deploying this. Think of this as the pre-flight checklist for a smooth rollout. All right, this is rule number 1, and it is non-negotiable. Before you can do anything else, you must have the Security Virtual Image, or vImage, uploaded to your vManaged software repository. This image is the engine that actually powers all these advanced security features. No image, no security. Period. Next up, you need to make sure the types of traffic you want to protect are actually supported. As you can see in this table, the basic reputation check covers a lot of ground: web, email, file sharing, and so on. And the really big one to notice here is HTTPS. So yes, this can inspect encrypted traffic, but you do need to have a decryption policy in place first for that to work.
And while we're on the topic of what's supported, there's a key distinction with file types. The initial reputation check is super broad. It can inspect everything from executables to zip archives to media files. The deep sandbox analysis, however, is much more focused on the high-risk file types that attackers love to use, like Office documents and PDFs.
And finally, this is a really crucial point when you're planning and budgeting. The base file reputation feature is part of your core SD-WAN security license. But to unlock the power of the Threat Grid sandbox for analyzing all those unknown files, that incredible afterphase of defense, that requires an additional, separate license. It's an add-on capability, so make sure you account for it.
So as we wrap this up, the big takeaway here is that this is about a fundamental shift in how we think about security. It's about moving from a model that only looks forward to one that can also look back. It's about building a defense that is always learning. So the question to leave you with isn't just about whether you can stop today's attacks, it's whether your network is truly prepared to find yesterday's threats, the ones that might already be hiding inside